Can someone speak? I'm not sure if I'm able to hear you guys.
Can you hear me?
Yeah, it's
Hello.
clear.
Voice is audible, guys.
Hello. Shivani,
Yeah.
can you hear me?
Yeah, I can hear you guys. Sorry.
Perfect. Perfect. Perfect.
Yeah.
Okay,
Okay.
so this is the first question of module 3 that we're going to discuss. We're going to discuss question number 1 to 8 from module 3. So draw the vector 1 comma 1 and find out all those points perpendicular to this vector. Shivani, can we draw this vector on GeoGebra?
Yeah. Okay. So this is the question. Let me open GeoGebra.
Yeah.
Okay, let me share the link for GeoGebra again. Can you share the link for GeoGebra to everyone?
Yeah, just a second.
Maybe they can try it by themselves first.
Guys, you can try plotting the vector 1 comma 1 in GeoGebra and see which points do you think perpendicular. But
Okay. So
1 minus 1 and minus 1 and 1.
don't they? Okay. Let's go slowly. So let's say u is equal to 1 comma 1,
1.
right? So everyone can see that this vector is 1 comma 1, right?
Right, right,
And now we want to find all points that are perpendicular to this vector,
right, right.
right? So let me think of a point that is perpendicular. I can think of, say,
Minus 1 and 1.
I mean, a point can't be perpendicular. I mean, I can take a point and drop a perpendicular to it. So I can't really say what points are perpendicular to it, but I can say what vectors are perpendicular to it.
Yeah,
I think
let's
that's
do
the question.
vectors. I think that's the
Okay.
question. I guess that
Yeah. Is it possible to remove that sound when people join in?
let me see.
Not sure how to do that.
Okay, I can't change it. I think only Sir can change it.
Okay. I can't even think of. Okay, I can only think of lines as perpendicular to this vector
Yeah,
because
yeah, it doesn't make sense, right, to have points.
yeah, it doesn't make sense to have points, nor does it. I mean, the yeah, okay. If I think of a vector, that vector there's only one particular vector, right?
Right,
Or one particular vector that
mm,
can be scaled up and down, right?
right, right. One particular line. Yeah,
Okay. Let's try the vector 1 comma 0, right? Or 0 comma 1, maybe 0 comma 1. Now I want the dot product of what does that give me? I can't get the dot product, is it? Yeah, we can get the dot of u comma v, which is says it's 1.
mm,
So what if I move v? Yeah, okay. So now, so what I'm essentially doing is I have a vector u and I want to find the vector that is perpendicular to this, right? And
right.
we know vectors start from 0, 0, right? And
Yeah,
the property I'm going to use to find the perpendicular is that the dot product of two
Vectors is 0.
yeah, when the
If
dot product of two vectors is 0, it means the
Can
yeah.
anyone tell us what this property is? If you guys have studied, some of you possibly have studied this property before. Can you tell us what the property is regarding dot products and perpendicular?
Yeah.
It is 0.
Yeah, why?
Right.
Maybe why also? That would be nice.
The dot product
Cos,
is
cos 90 is 0.
Or you can, I think two
Yeah.
people spoke at a
Because
time.
their projection on the each of their other vector is 0.
Hmm.
Okay,
Okay,
that's a
any
good way
other
to think
answers?
about it. Nice. So projection is basically the shortest distance between this vector and this vector, right? What I would draw. So you're saying if the vectors are perpendicular, then the drop would just be along that vector, right? That's what you're trying to say. Okay, maybe we can even write this down if that's okay.
Yeah, maybe you can open that, Jenny.
Yeah.
So the dot product is the measure of alignment between two vectors. It tells you how much aligned they are.
So don't mind me if I'm not looking at the screen. Yeah. So the first question asks us, so we drew the vector one, one, right? And now we want to find, say, find the vector perpendicular to this.
Right.
So for that, okay, for that we're using the dot product. We're making, so one dot of two vectors u comma v. When the dot product is 0,
That
we
means
say, yeah,
U and V
these
are perpendicular to each other.
two vectors are perpendicular.
You guys
So
also okay. Does anyone here also knows why we say when the dot product is 0 that the vectors are perpendicular?
yeah, what is the dot product? What is
Yeah,
it
what
doing?
is the dot product? What is U dot V? What is U dot V?
Mod u, mod v, cos theta.
And
Okay.
what does mod U and mod V represent?
Mod u is the magnitude of u vector. Mod v
Correct.
is the magnitude of v vector, and cos theta is the
Angle
theta is
between them.
the angle between them.
Perfect, perfect. So when your cos theta is 90 degree, your angle
Yeah,
between your dot product would be 0,
yeah, exactly.
right?
So when theta is equal to 90 degrees, what happens?
Cos theta is 0. Cos 90 is 0, right?
Yes.
So cos 90 is 0, then your dot product is also 0.
Yes.
So now we've seen why we are using this property and how we've come to this property. Now we'll try to find a vector that is perpendicular to the vector 1 comma 1.
Any doubts so far? Maybe
Yeah, if
pretty
anyone has any
straightforward,
doubts,
right?
they can they can raise their hands if anyone has any doubts regarding this, or maybe you don't know what dot product is or something else. Anything, even if it's basic, we don't mind it. You can tell us. You can raise your hand, type in the chat.
Or maybe we can take an example as well.
Yeah,
U is equal to 1, 2. V is equal to 3, 4.
So a dot product, can someone tell us what a dot product is? How we do dot product?
Yeah. How do I
Basically,
take? Yeah.
basically what you're going to do is find the projection of one vector on the other, and then you multiply both of them.
How do we do that?
So that's what for finding the projection is what you do by doing cos theta. So u cos theta is the projection of u on v. So then you just multiply those two to get the result, the scalar product, which is only it only has the magnitude because the direction is the same. You know.
Okay, anyone else? Apart from Shriram, anyone else would like to tell us how do we get the dot product of these two vectors?
Yeah. What about the steps? So how do you? Okay. So you said it's the magnitude of u and magnitude of v. How do I find the magnitude of u and magnitude of v? How do I know the magnitude of a vector?
Yeah.
Root
Anyone?
of x square plus y square.
Yeah, go ahead, go ahead. Go ahead.
Yeah.
Somebody was saying something. Sorry to interrupt. Can you tell us what the magnitude of the u vector is?
How do I
Anyone?
find the magnitude of a vector?
The
What is
last point in it, the endpoint of the endpoint coordinates x comma y. Then the magnitude is root of x square plus y square.
Perfect. So you
Yeah.
know how to plot a vector, right? So if your vector is 1 comma 2, then that means 1 unit in the x direction and 2 units in y direction. So you find the magnitude of it by Pythagorean theorems, right? Guys, anyone didn't get in this part? They can raise their hands.
Maybe someone can help me with the spelling of Pythagoras. Pythagoras?
Yeah.
G-O or
Arias.
G-A?
Goras.
Thank you. Okay. So yeah. So I want to find the magnitude. Magnitude, maybe we can also define it as at the length,
Yeah.
right?
So the length of this vector represents its magnitude, and the arrowhead represents its direction, right?
Yeah.
So a vector has a magnitude and a direction.
Yes.
Yeah. So it would be 1 square plus 2 square, right?
That is root 5. Root of 5.
Yeah. So I will define the magnitude as root of 1 square plus 2 square, which is nothing but root 5, right?
Yeah, right.
Awesome.
And similarly, can we also define the magnitude of vector v?
Yeah. Before that, one other way to find the magnitude of I mean, a vector is nothing but taking its dot product, right, with
Right.
itself,
Correct.
and taking the square root of the dot product,
Right.
right?
So that will also give you the
Idea of what a dot product means.
right.
Yeah. So does anyone want to expand this side? How do I take the dot product of 1, 2 with 1, 2?
Anyone?
We can just multiply like first component of both the vectors with the second
Corresponding
component.
components.
Yeah.
Awesome.
Mhm.
Okay. So
Perfect.
1 into 1. Okay.
Plus
Plus
2 into 2.
Perfect.
equal to 5. And I want the square
And
root of
square
it.
root of that is square root of 5. That
Yeah.
is the magnitude that you get, right? So now you have two methods of doing it. Can someone tell us what the dot product of the magnitude of vector v is going to be?
Yeah.
Yes, it is.
Mhm.
Can you say what the vector v is also once?
Yeah, sorry, my bad.
It's 1, 1.
I think it's 3, 4, right?
The previous one was 1, 1.
Is it? 3, 4. Vector v is 3, 4.
Okay.
My bad, I didn't notice it.
No, sorry, my bad. I should have. Yeah. So vector v is equal to 3, 4. So what is the
Right.
norm of vector v?
Anyone? Guys?
It's 5.
It's
There.
5.
Yeah. So it's, sorry, 1 second.
Okay, just to be clear, if anyone doesn't know the term norm, it just means the magnitude of that vector.
Yeah.
So norm is just another name for magnitude or the length of the vector.
So I'll say the norm of the magnitude of the vector is 3 square plus 4 square, the whole square root.
That gives you 5,
Square root of
25.
Yeah. square root of
16
25.
plus 9,
Yeah.
25. So the magnitude of this vector v is 5. That is the norm of this vector v as well. Perfect. Now that we have magnitude, somebody was explaining us how we get the dot product. So
So let me write the two. So the norm of u is root 5.
yeah, and the norm of v
Now
is 5.
5. And now I want to find the dot product between u and v.
Anyone, guys?
You just have to do mod of the norm of u and norm of v times cos theta.
Yeah.
The angle between those two.
Yeah.
Mhm.
So I know norm of u and I know norm of v. How do I find the angle
The
between them?
theta.
You especially it's you use the scalar if you have to know either the scalar product or the cos theta in order to find each other. You can't have two variables and then
Okay.
No, somebody told us this method. That's why we proceeded with this. We wanted to see what the dot product is going to be, how they are going to find out the dot product. That's why I asked
There is
somebody.
another method too.
Yeah. Go ahead.
Product of the x coordinate plus product of y coordinate.
Okay. Perfect.
Okay. So you want to do it like the way we did it for u dot u. Okay. So you want to take 1, 2 with 3, 4. Is this enough?
but the problem is you're assuming that cos theta is 1, that is theta is 0.
Anyone?
Right, there is still going to be cos theta multiplied to it, right?
No, the product of the x coordinates plus product of y coordinates.
Yeah, if I take, okay, so when I meant, okay, just like how we did 1, 2 dot product 1, 2, I did 1 square plus 2 square, right? Similarly, I'm going to do the same thing, like you said. I'm going to take the product of the x, so 3 times, so 1 times 3 plus 2 times 4, right? But these two sides are still, so this is not equal to this exactly, right? Because let me maybe make some space for it, right? Because if I want to equate the both sides, I need to have cos theta in between.
This would actually give you the dot product. So 1 into 3 plus 2 into 4 gives you the dot product of these two vectors.
Is it? Okay.
Yeah, it does.
So cos theta is a part of it, is it? Sorry.
So I was very curious when somebody said, okay, we should proceed with the other method because dot product is quite simple. Dot product of two vectors is quite simple. You just have to multiply the corresponding values of the vectors and sum them up.
So this is equal. So yes, okay. So this is equal to u. I mean, if I take the how do I say x coordinates?
So you can say u1, okay, x1.
Yeah, u1 makes more sense. So u1, u2 dot.
So u1 into v1 plus u2 into v2.
One plus. Okay.
Okay. So that is the dot product of those two vectors. If you have the theta, if you have the angle as well, then you can proceed with the other method as well. Okay. If you have the angle between the two vectors, you can go ahead with the other method. But if you don't, then you can directly do this as well. Okay. Now that we have found the dot product, now that we have understood what a dot product is, now we can go back to the question. So the question was, draw the vector 1 comma 1, find out those vectors that are perpendicular to this vector.
So maybe we can look at the dot product. I've mentioned A is equal to u dot v, right? And currently the dot product is 0.5,
So
0.4.
we get it to 0 and
I don't know if I can exactly get it to
we will,
zero.
yeah.
Can-
Is there a way
Yeah,
to do
it's-
it? Ah, yeah, that's it.
Yeah, I
So
know.
we'll go with the basic graphical method. We'll try to find out which vector is perpendicular to this vector. We won't go into the mathematics of it. Not right now, at least. We can discuss that part later. So can everyone see this vector that is perpendicular to this vector 1 comma 1? And can
Yes.
you also tell us, is there only a single vector such
No,
that
there's only a single direction such that this satisfies, but the vectors you can have all kinds of magnitudes, still it will be able to satisfy.
perfect. So there's a line that is perpendicular to this vector. Every point on that represents a vector that is perpendicular to this vector 1 comma 1. Am I right, guys? If anyone has any doubts or any counter arguments to that, you can raise your hands. Yeah, right, Ajit. Okay, so perfect. Now we know which line is this. This is y equals to minus x, right? So every point that lies on this line is perpendicular to this vector 1 comma 1.
No, every vector that lies on this line.
Yeah,
So,
that point represents a vector, right? Every point on this line represents a vector. Or
yeah,
and
yeah, because I can take any point and I can drop a perpendicular to that line, to that vector. But I can only think of the vector because it starts from 0, 0. I can say, yeah, every vector that is on this line, which can be maybe represented as points. Yeah.
Yeah. So when we say vector, we got a point 1 comma 1. We drew this vector because we knew the tail is going to lie on the origin. So when we say that every point on this line can represent a vector that is perpendicular to this vector 1 comma 1, that is because we already know the tail lies on the origin. Okay, so that's why we can say that comfortably. Okay, moving on to the next question. So you say that, so the next question is, do you observe that we are asking for vectors x comma y such that x comma y multiplied with the column vector 1 comma 1 is equal to 0 comma 0. So what is that 0 comma 0? Can anyone tell us? So we had a vector, a row vector x comma y with a multiplied with the column vector 1 comma 1 equals to 0 comma 0. What is this x comma y? Can anyone relate this to the graph we just saw on GeoGebra? That figure that of two vectors that we saw. Not two vectors, one vector and a line. Can anyone relate this with this?
Let me revisit the question. Sorry. So do you observe that we are asking for vectors x comma y such that xy? Okay.
Okay, did not understand the question. No worries. We'll again discuss this question. So we have a vector 1 comma 1 that is multiplied with a row vector x comma y, and the output is 0 comma 0. Okay.
It
So
will be only 0.
pardon?
The 0,
No,
it
no,
will be not 0 0. It will be only 0.
no. Let's look at this. Xy is a, what is the shape of this vector? I mean, okay, so xy usually written like this, right?
Right.
So this is maybe the transpose of this.
Yeah. So you have the transpose of that
One
vector.
cross two.
I'm saying it will be 1 comma 1 matrix. No?
Yeah, that's correct.
Oh yeah, maybe it's the other way around, is it?
Actually,
It
when
should
we
be,
do
I guess.
row multiplication, we usually put it at the other side. The one should be at the other side.
1 multiplied with x.
Can you tell me the logic why we are writing means just a second. Okay, it's question that we are
Okay,
asking.
maybe he means the dot product of xy, right? Maybe because
Yeah. So
okay, maybe
Actually,
that also doesn't
this
make
maybe
sense.
is. Go ahead.
Yes.
I mean, I guess the question is that so in this case, I maybe we just expected to find like
This is the
someone's
same
actually
thing.
posted the answer in the chat too. Like,
The
so
thing
what
is,
are the x and y such that xy into 1 equal
So
to 0
the
0?
earlier question was we had to find all the vectors that were perpendicular to the vector 1 comma 1. What we did in that question is exactly in this question as well. We are doing exactly that in this question as well. So there
Okay, joined.
we took the dot product of, we said that if the dot product of two vectors is 0, then that means they are perpendicular to each other. What are we doing here?
Okay, yeah,
Aren't we doing
okay.
the same
So
thing?
the reason why that came is that like mostly when you denote dot product in matrix multiplication form, you write xy transpose into the vector
Right,
equal to, yeah, that's the
right,
reason why it's written like that.
right, right. So it's the
but,
same thing. Yeah,
but
go
right
ahead.
now it would be 0 now only.
Yeah,
Not
it will be 0. It will be 0. So dot, since we are finding the dot product, it would be a single integer value, a real value. So can you all relate with this? So what we did is x comma y multiplied with 1 comma 1. So our x transpose multiplied with our vector 1 comma 1. So we had that vector that we plotted in that graph, right? Can you open GeoGebra? Yeah, right. So you have this vector q here that is 1 comma 1. You multiplied some unknown vector with that such that it gives you 0 comma 0. That means whatever the input is, whatever your input x comma y is, it should be perpendicular to your vector 1 comma 1. Did you guys understand that? Or if anyone who didn't understand, they can raise their hands. if anyone who cannot see the similarity between the first question that we discussed and this second question. Okay.
Yeah, if it isn't too much trouble, can you brief about what that question was? Because I joined a bit late.
It was just a question that draw a vector 1 comma 1 on GeoGebra and find out all the vectors that are perpendicular to that. So all the vectors that are perpendicular to that lie on the line y equals to minus x. So that was the question. So how did we get there? We took the dot product equals to 0. So if the dot product is equals to 0, there we found that graphically.
Yeah,
We found that line graphically, that is y equals to minus x. Now we try to relate the second question with the first question. That the input, if the dot product of input and the vector is 0 comma 0, so sorry 0, then that is our perpendicular vector to the vector 1 comma 1. It's the same thing we've discussed in the question number 1 as well. Guys, understood?
just another
Everyone?
way to write the same thing. Yeah.
Same thing. Same thing. Okay, I'll assume that everybody has discussed, understood that properly. If anyone who hasn't understood that, you can type in the chat. Okay, we can move on to the third question. So the third question says, use GeoGebra and solve the above question with 1 comma 1 replaced by a comma b. Use a and b as parameters and check what happens to x comma y. So yeah, can we use a and b as parameters? Just type a
I
and
mean, we can find that using the metrics too, right? I think that's what the question
Let's
asked.
go step by step. No, no, I
but there
think-
are
Yeah.
the
They
question
just want
specific.
us to replace the vector 1,
Oh
1.
yeah, it says use GeoGebra.
Yeah,
My bad.
sir has specifically mentioned even in the chat that try to use GeoGebra as much as possible. So we'll try to stick to GeoGebra as much as we can. So no, as parameters, Shivan, a just delete that a enter and b enter, and then define a vector with a comma b. So a enter, b enter, and define a vector a comma b.
What do we mean by parameters?
I mean, for any a comma b, we can find a generalized solution. Like if instead of 1 comma 1, say a equal to 1, b equal to 1 means it's one possible solution. So when we use other values of a and b, what do we get? Like we can find the solution in terms of a and b, I guess.
Yep.
Okay, I guess that was it.
Does anyone remember the in plus 2 we used to study parametric equations?
Yep. Yeah, it's kind of
Yeah.
that.
So is there some relation or what?
So then our v is x comma y.
Parametric equations were a bit different. If you see, like for the line, then it was not the usual way, like you were writing y is equal to mx. It was something like y. It was just written in the form of just relation of 2 points only. But here the parameter is just like a different, a varying input that we can set.
No, our v is x comma y. Our v is x comma y. Our a that was 1 comma 1 earlier. We replaced it with a comma b, and our v is x comma y. So if we vary the value of a and b, what happens to our v is x comma y, x comma y.
I think you can't type that.
Can you not do it?
He would have to declare X and Y first, no? X and Y are not declared. Oh, no.
Mhm.
No, just X enter.
So you can find perpendicular vector by writing it perpendicular vector.
That's what I wanted. Thank you. I'll do that. So we want to find the perpendicular vector, right?
Right. To this vector, yeah, perpendicular to vector to A comma, sorry, U, perpendicular vector to
Yeah, that's
vector
what we
U.
got. It.
So yeah, so this was our earlier vector 1 comma 1. And can you change the range of A and B as well? Yeah, that would be.
How much? Right. 10 is enough, right? 10 and minus 10?
Yeah, it is 10 and minus 7. Perfect. 10 and minus 1. Ajit, can you stop doing that?
Okay, so he asked us to vary A and B, right?
Hmm.
So let's keep, okay, so does anyone want to give us some values of A and B?
Guys?
2, 5.
Or do you
Yeah,
just want me
5,
to
Okay.
vary
7,
it along?
something.
Okay, so let's move it to 5, 7. Okay, not a click it.
Let me put the link in the chat box as well. You guys can try it simultaneously as well.
You want me to give you the link? Simultaneously, I don't think they can, or I don't know how it works. Is it collaborative or?
Not collaborative. I didn't mean that.
Okay. So I've gone to 5 and I'm going to 7. Can we see how it's moving around? Like the perpendicular is.
So if the vector is x comma y, the perpendicular is minus y comma x.
Yeah.
Yeah.
Right.
So let's give any other vector 1.2 and
Or
3.
if somebody wants to relate it to the earlier concepts that you guys might have learned. So
We
we have
actually have
linear.
to find the like the equation, right, in terms of A and B, which give you the perpendicular, the equation of the perpendicular, right? So that's what I thought.
No, there's
What? You just
nothing
have to
like that.
check
We
what
just
happens
have
to
to
x comma
notice.
y.
Yeah. We haven't come to that point yet.
What happens to x comma y means, I guess, we have to find, what happens to x comma y. What is the image of
We
x comma
just
y?
have to notice what is happening to x comma y. Our x comma y is the perpendicular vector to our vector u. That's it. We just have to notice what's happening. And Shriram rightly mentioned what was happening to this vector. So if anyone wants to relate it to the earlier concept that you guys might have studied is linear equations in one variable. So your perpendicular line, the slope of your perpendicular line is actually what? Can anyone tell us? Slopes. Talking about slopes of two perpendicular lines here.
Product of slopes. Yeah. Is it just for me? Like I think someone's speaking, but it's not that clear. Or someone was.
Okay, can anyone tell us what the relation of slopes of two perpendicular lines are?
-1.
M1,
They're
M2 is equal to
produced.
-1. Related to other.